Hello students, today we will study lens. What is a lens? A lens is an optical instrument having two reflecting surfaces. As we know, a lens is a reflecting surface having two lens. A lens is an optical instrument. A lens is an optical instrument having two reflecting surfaces. It means a mirror has single reflecting surfaces, but a lens has two reflecting surfaces, and both reflecting surfaces may be walled outward or walled inward. On the basis of whether reflecting surface is walled inward and outward, a lens may be a convex lens or a concave lens. A convex lens is a lens whose reflecting surface is walled outward. A convex lens is a lens whose reflecting surface is walled outward, and a concave lens is a lens whose reflecting surface is walled inward. Now we will study some more basic terminologies. Here a question arises that whereas in case of mirror we had studied that a mirror has single principal focus, single center of curvature, but in the case of lens, as lens has two reflecting surfaces, it means when a ray comes from either of the side, either leftward or rightward. Suppose a ray is coming from leftward, it may pass outward, rightward. So a lens has two reflecting surfaces, hence a lens has two focal length or two focus. It is an important question for class 10th level, why a lens has two focal length. So the simple answer is that as a lens has two reflecting surface, as lens has two reflecting surfaces, so lens has two focal length, one to the left and another to the right. Now we will study the path of rays when a ray of light strikes on a lens. Then we will study nature, size and position of the image formed when an object is placed in front of convex lens. So steps to plotting ray diagram. A step to plot ray diagram for convex lens. First, say that a ray of light incident parallel to the principal axis will pass through F2 after reflection. F2 means principal focus of the other side. This is a convex lens. This is the optic center O, F1, to f1, f2 to f2. Suppose a ray of light which is parallel to principal axis. A ray of light parallel to the principal axis. It will pass through f2 after reflection. This is the first ray diagram that we have to study. Second says a ray of light passing through the focus of convex lens will reflect parallel to the principal axis. It's reverse. We have to keep in mind that when ray of light is parallel to the principal axis, it will pass through f2. Whereas if the ray of light incident through f1, it will reflect parallel to the principal axis. This is optic center O. This is f1 to f1 infinity. So if a ray of light passing through f1, it will reflect parallel to the principal axis, f2 to f2 infinity. Second case, if the ray of light pass through principal focus, that is f1, it will reflect parallel to the principal axis. Second case. Third case, a ray of light passing through optic center of the lens will pass through. A ray of light passing through the optic center O will pass through the other side. Okay. This is optic center O. If a ray of light incident at O, it will pass through. These are the three rays which will help us to plot ray diagram. But before that, we will study nature, size and position of the image formed when an object is placed in front of convex lens at various places. As in the case of mirror, we had studied there were 6 positions where an object could be placed at infinity, between infinity and center of curvature, at center of curvature, between center of curvature and principal focus, at focus, and between focus and mirror. In the case of lens, there will be also 6 positions where an object could be placed. First case, here f1 to f1 and infinity. First case will be at infinity, between infinity and 2f1, at 2f1, between 2f1 and f1, at 2f1 and between f1 and optic center. There are 6 positions where an object could be placed. Again, let us recall: at infinity, between infinity and 2f1, at f1, between 2f1 and f1, at f1 and between f1 and optic center. Hence, the object being at infinity, its image will form at f2. Hence, the object being at infinity, the image will form at f2. and as the object will move towards the lens, the image will move away from the lens. As the object will move towards the lens, image will move away from the lens. It means as the object will between infinity and 2f1, the image will form between f2 and 2f2. As the object will at between infinity and 2f1, image will form between f2 and 2f2. As the object at 2f1, image will form at 2f2. Clear? As the object will between 2f1 and f1, the image will form between 2f2 and infinity. Had the object been at f1, image will form at infinity. Infinity 2, मतलब infinity of other side. And had the object been between f1 and optic center, image will form at the same side. Clear? What we have? Let us recall again. Had the object been at infinity, image will form at f2. As object will move towards the lens, image will move away from the lens. It means had the object been between infinity and 2f1, image will form between f2 and 2f2. Had the object been at 2f1, image will form at 2f2. Had the object been between 2f1 and f1, image will form between 2f2 and infinity. Had the object been at f1, image will form at infinity, and had the object been between f1 and optic center of the lens, image will form between same side. This is the position of the image. Again, about nature. All the images will be real and inverted if the object lie between infinity and f1. Had the object been between infinity and f1, all the images will be real and inverted. Whereas, if the object lie between f1 and optic center, image will be virtual and erect. Clear? Had the object been between infinity and f1, images will be real and inverted. Had the object between f1 and optic center, image will be virtual and erect. About size. If the object is an infinity, image will form at point size. If the object lie between infinity and 2f1, image will form between f2 and 2f2, and image will be diminished, that is smaller. Had the object been at 2f1, image will form at 2f2 and it will be of same size. Had the object lie between 2f1 and f1, image will be 2f2 and infinity, it will be magnified. Had the object at f1, image will be formed at infinity and the image will be highly magnified. And in the case of object at between f1 and optic center, image will be magnified. Okay. So this is the nature, size and position of the image formed. And now you may write, may make a table, but better learning this as table, learn this as a trick. Now let us plot ray diagram for the lens for object placed in front of convex lens at various positions. So let us remind about case 1. Object at infinity. In case of object at infinity, all the rays of light will be parallel to the principal axis. And as from the ray of path, we have studied that when a ray of light is parallel to the principal axis, it will pass through F2 after reflection. It means if the object is at infinity, image will be, in the case of between infinity and f, image will be real and inverted. It will be of point size and will form at f2. That is principal focus of the other side. Had the object at infinity, image will be real and inverted. Image will be of point size and image will form at f2. Next, had the object lie between object is situated between infinity and 2f1. Had the object lie which is situated between infinity and 2f1. Now then draw a ray diagram. This is f1 and 2f1. Our object like this. So, how will we plot ray diagram? One ray will be parallel to the principal axis, which will pass through optic center through f2. Another ray will pass through optic center and the image will form between f2 and 2f2. Image will form between f2 and 2f2. Okay. Then in this case, image will be real and inverted. Real and inverted. Image will be diminished, that is smaller than object, and image will form between f2 and 2f2. Second case, third case. Clear? It means one ray will incident parallel to the principal axis, which will pass through f2, and another ray will pass through optic center, which will pass to the other side, and both of them strike between f2 and 2f2. In that case, image will be diminished size. Now, third case, image is situated at f2. 2f1. Image is situated at 2f1. Then let us see what will be nature, size and position of image in this case. This is optic